Hi, good evening, everyone. Uh, I'm seeing over there. So let's wait for 5 minutes and then we'll start. Okay.
Okay.
Okay. I think so. Let's start the session. Okay, I'm going to share my screen. So today is, I think this is week five. Solve the session. Okay. And this is very easy week. So maybe I don't think you guys will feel too much of the attraction here. Okay, so go to the joinpd.com as we were going previously. Go to the joinpd.com, enter this code there, CFUMHF. So go to the joinvideo.com and use this code there, CFU MHF. Okay, so I think so the 90 students have joined. Others, please join the session. Go to joinvideo.com and use this code CFU MHF. And now we'll start the first question maybe. Okay. Okay, this is prelude 1 to question number 1. There are 10 shirts, 15 pants, and 20 kurtas. Raj has a gift voucher with which he can buy one item from above categories. So there are total of how many entities are there? 45, right? 10 shirts are there, 15 pants are there, and 20 kurtas are there. Now has a gift voucher with which he can buy one item from above categories. So I think in the previous session, which was held on Tuesday, we have discussed about this. So now what are the total number of different ways in which Raj can use this gift voucher? So one gift voucher is there and he has to choose one among these three. Like this shirts, pants or kurtas. How many ways will be there?
45.
Oh, you can just enter your answer into the joint period.
Done, sir.
Okay. So wait. I think now 13 students have responded. So we'll wait for 1 more minute and then we'll discuss the solution.
Can I ask one doubt
Regarding
regarding variance, sir? Just a concept.
variance, no
Yeah.
vari. I think we'll take it at the end of the session. Okay.
Okay,
So
sir.
is it related to which question like
It's not a question, it's just a
uh,
concept. Yeah,
concept of
actually,
variance?
yeah,
Hmm.
sir. Actually, we find a variance for data set, that is totally fine. But
Hmm.
if I have a two data set and find the variance for a particular field, so I
Hmm.
get some numerical value. For example,
Hmm.
if I go age and years, for example, student and term one marks. So for
Hmm.
term one marks, I will get one variance.
Hmm.
And the same students, and I'm going with term two, so I will
Hmm.
get another variance for that one.
Hmm.
So I have a two variance. So what is the info from this variance? So that's my question. I have a variance, that is a numerical
So
value. I
so
get.
that's why we have the concept of covariance, right? Where we use this information to understand what is the association between these two variables, correct? Because
Yes, sir.
if you see the formula of covariance, what is it? It's
Um,
or not covariance, I will say correlation coefficient. So in
okay.
correlation coefficient, what you do is you find covariance and you use those standard deviations, right? Uh,
Yeah.
uh, and standard
That,
deviation is nothing but a variance, correct?
yes, sir. That's concept clear, sir. But
Mm.
you have a data set, I find a variance. So what
Mm.
that variance actually tells? So mean tells something, median tells something, mode tells something, but variance tells what? That is the question, sir.
Variance tells the variability of the data about the central tendency. For example, let's say what does the main tells you for, let's say one. Okay, we will take the example of two variables.
Measure of dispersion, sir.
Right. Yeah. So so let's say one is, let's say, area of the house and another is number of bedrooms, for
Okay.
example. Okay, these are the two my variables. So let's say the mean of the area is maybe some 2000 square feet. Okay, and the
Okay.
mean of number of bedrooms is let's say three bedrooms.
Okay.
But these two are different things, right? Number of
Yes.
bedrooms is a different variable, and uh, we are so currently when you find mean of the or average area, let's say 2000 square feet, what does that infer to you?
Um.
So you are saying that we have that these many examples. For example, let's say we we are talking about 200 sorry 200 houses here, and we are saying that the mean area of this 200 houses is 2000 square feet, right?
Okay. Okay.
What does that tell me? Whatever
That,
data I'm having, the central it gives me the central tendency, right?
Yes.
So average area per house is 2000 square feet.
Yes.
So that means this is the middle value
Yeah.
of the area, right?
Yes.
Where and there are other like so, but this middle value comes out. So what does you okay? Let's talk about standard deviation here. So standard deviation is nothing but the square root of the
Square root
variance,
of
right?
variance. Yes.
Okay, I'm sorry. I'm sorry. So square root of variance, right?
Yeah.
Let's say the standard deviation of area of the houses is, let's say, 100 square feet. Okay.
Okay.
Okay. And okay, this is one of the cases. And let's say in another case, the same variable area I'm talking about, and I have taken 200 some different examples. Okay.
Okay.
So for first 200 examples, my average area is 2000 square feet. For another 200 example, I'm having also the average is 2000 square feet. Okay. But
Okay.
now consider that the standard deviation for the first 200 example is, let's say, 100 square feet,
Yes.
and the standard deviation for the other 200 example is, let's say, 500 square feet.
Okay.
What is the difference between these two standard deviations, even though the mean is same, right?
Yeah. 400.
So what does that infer is, about my 2000 square feet. So 100 standard deviation means what? Most of the data lies within 1900 to 2000 100, right?
Yes, sir.
That's
It's clustered around mean.
around mean. But again, see, around mean is okay. So it's like that means 2100 square feet and 1900 square feet, right? So
Yes.
most of the my data, it is surrounded within that, right?
Yes.
Within
Yes.
that. These 200 examples, what I can think of is, with the information of mean and variances. So whenever I'll go to this 200 houses, right, to
Yeah.
check these 200 houses, what happens is my area mostly comes. So each house is having the area within this range, right?
Yes, sir. Yeah.
So
Yeah.
the house might be 1900 square feet or 1950 square feet, or
Hmm.
2000 square feet, or 2100 square feet, or
Hmm.
2050 square feet, like that.
Hmm.
But each of these 200 houses are within this range, right?
Yeah.
Similarly, if I go with the other 200 examples where I'm saying that the average is 200 square feet, sorry, 2000 square feet, but the standard deviation is 500 square feet. What does that mean is, uh, there is like a lot of variation in the data, right?
Yes.
So you
Yes.
can see
Yes.
that there are 1500 to 2500. So if
Yes.
when you see this 200 examples, I can see a lot of houses are having 1500 square feet, or 1600 square feet, 1700, 1800, so in that category, right? So most of my data is lying within that. So it shows the spread of the
Yes.
data,
Yes,
how
sir.
your data is spread over the
Over the
uh,
mean, that central tendency mean.
no, it is around the mean, but over that, yeah, so you can say over those values, right?
Hmm.
So most of my 200 examples, right, they are within 1500 square feet to 500 square feet, and in another case it is between 190 so 1900 square feet to 2100. So
2100 square feet.
I will take one more example. For example, let's say there are two cricket players. Okay, this is so let's say the average of one player is 40 runs. Okay,
Okay.
and the average of another player is, let's say, 41 runs. Okay,
Okay.
40 runs, one player average, and another player's average is 41 runs. So
Okay.
first player who's having average 40, he's having standard deviation of 1 run. Okay,
So what is the standard deviation?
1 run, or maybe take 2 runs.
Okay. Okay. Two
Two
runs.
runs,
Okay.
okay. And these two players have played, let's say, 200 innings each
Yeah.
separately. Okay, and the second players, whose average is 41, he's having standard deviation of 10 runs. Okay,
Okay.
so
Okay.
who is the consistent player in this two? The player who's having average 40, or the player who's having average 41?
So, are you telling that the average 40 player has standard deviation is 2, right?
Mm-hmm.
So that means the maximum of value is around the central tendency. So that is very tightly clustered in that range.
So that player has scored, like, in each of the inning, I can say, within that 38 to 42, right?
Yes.
So
Yes.
each time
Yes.
he'll go, he will play at least 38 runs,
Okay.
39 runs, or like that. It
Yeah.
might be like 35 some days, or maybe 0 some days, but mostly this data is within this range, right?
Yeah.
38 to
Yes,
42.
sir. Yes.
While the other player who's having average 41, which is more than the first player, right? But
Yes.
his standard deviation is 10 runs. So sometimes he scores very low values,
Yeah.
consistently low values. Sometimes he scores very high runs, right? That
Hmm.
means the second player who's having better average, he's not a consistent player, right?
Yeah.
So whenever
Yes.
you are thinking about any player who you wanted to, take confidence, like who that guy will, so you'll go with the 40 run with 2 standard deviation. That means
Yes.
you'll have the confidence that this guy will go and at least he'll score 38 within that range, right? So he
Yes.
won't,
Yes.
so consistently he will play the runs, right?
Yes,
While
sir.
the other player, he will score someday very high runs. Let's say
Yeah.
sometimes 100 runs,
Huh.
sometimes 150 runs, but sometimes most like a lot of times he'll score very few runs. That's why his
Yes.
standard deviation is like this, right?
Yeah. Yes, sir.
So
Yes, sir.
that is the physical importance of the variance or standard
Yes.
deviation.
Yes, sir.
Okay, but
Yeah.
mostly we don't use variance because it is a square of standard deviation,
Huh.
and most of the times what happens, so area when we measure is, let's say, meter square, right? So
Yeah.
variance, the unit of variance will be meter raised to
Meter
4,
square. So square
and
root.
that we can't, so with standard deviation we can, uh, what do you say, connect that standard deviation with the data, and we can visualize it better. So
Yes.
mostly we'll use the standard deviation. Okay.
Yeah. Yes, sir.
Okay. Okay.
Thank you so much, sir. Clear, sir.
Okay, fine. Okay, so okay, I thought this is a fairly easy question, right? I like a lot of students have taken. Okay, it's 45, right? Why 3000? I don't understand. Okay, I don't know. So maybe some of you have multiplied this, but it's not multiplication because you have to choose one item from above categories. So either you can choose one shirt, right? So how many ways to choose one shirt? 10 ways are there,
10
right?
ways, sir. Yeah.
How many ways are there to choose one pant?
15.
15 ways. And how many ways are there to choose one kurta? Is 20.
20.
So you have to buy only one item among these 15 items, among these all these items. So you can actually either buy 10 shirts, like one shirt out of the 10, right? Or one pant out of 15, or one kurta out of the 20. So total ways will be 10 plus 15 plus 20. So this is the addition rule of counting, right? So Raj has to choose one item from the given categories. The number of ways he can select a shirt is equals to 10. The number of ways he can select a pant is 15. The number of ways he can select a kurta is 20. So Raj can select either a shirt or a pant or a kurta. Therefore, the total number of ways of selecting an item will be 10 plus 15 plus 20, which is equals to 45. Right?
Yes, sir.
Okay. Okay. So prelude to question number one is the same information is there. There are 10 shirts, 15 pants, and 20 kurtas. And Raj has a gift voucher with which he can buy two items. Okay, so these two items should be of different category. You understand? So there he can buy two items, and these two items. So if you one item if you have selected shirt, then the second item you cannot select a shirt. You have to select either a pant or a kurta. That you have to think of. So what are the total number of ways or different ways in which Raj can choose the gift voucher? So just take maybe 2 or 3 minutes and try to solve this question. Okay.
Completed, sir.
So it's not allowing me to press enter. I hope you are able to see the answers.
No, wait for a minute. Share will show the answer. You just enter and wait.
Okay, so I just have to type and it comes to you, right?
So actually, I'm not an instructor. I'm also a student. Actually, if you type and wait for a second, then share is changing the slide, answer slide, then it will show.
Okay, thank you.
Sir, your mic is mute, sir.
Oh, sorry. Okay, fine. I was talking. Okay, so 650 seems to be a answer because, and I think a lot of students have selected that one. So okay, here Raj has to choose two items, right? That is, these two items should be of different category, correct? Number of ways he can select a shirt and a pant is 10 into 15. So why you are understanding, right? There are two items, right? Or two items one has to select. So that means two spaces are there. So in first place, what will happen? You can either select and this the first place and second place cannot be filled with the same item, right? Okay, maybe I'll just try to draw.
Oh, am I audible?
Yes.
Hello.
Yes, you are audible.
Sorry.
Oh, hello.
Yes.
Mayur sir.
Yeah.
I have a doubt in this. The question says, how many ways he can select the item. So there are actually just three ways, right? Like he can either choose a shirt and kurta, and a pant and kurta.
Right.
So
Okay,
these are the three combinations that he can choose. That's it, right?
correct. So okay, can you tell me the how many shirts are there? 15, right?
Yes.
15 shirts, right?
And
Then 20. Okay, how many? Can you tell me once?
uh,
Okay, maybe I
the
think 10
numbers
shirts
were
are there.
10, 15, and 20.
Yeah, 10 shirts, 15 pants, and 20
20
kurtas,
kurtas.
right?
Yeah.
And now he has to select two items, right? So
Yeah.
this is this
Just
first. Okay, no, let me complete.
Yeah.
So this is the first place or first. So he has to choose two items to buy this gift voucher or to redeem this gift voucher, right?
Yes.
And these two items can be different, right?
Mhm.
So what are the different possibilities are there? Either he can choose a shirt or a pant, right?
Or a pant, yeah.
Maybe a shirt
And
or
a
sorry,
kurta.
or not or shirt
And
and
it is
pant,
and
right?
yeah.
Okay, shirt and pant, shirt
Shirt
and
and kurta
kurta, or maybe pant and
and kurta.
kurta, right? Okay. The order does not matter here anyway because he can either choose a shirt first and pant later, or pant first and shirt later. It does not matter the thing, right? Because
Yes.
anyway it's the same. So that means it's or, right? Again,
Yes.
shirt and pant or shirt and kurta or pant and kurta. These are the three choices he can do, right?
Yes.
So let's say he is going to choose this one, this way. So
Yes.
shirt and a pant. So how many ways he can select a shirt?
Oh, okay. Yeah. 10,
10.
10
10.
ways. Yeah.
And how many ways he can select a pant?
15 ways. Okay. Yeah.
15.
Oh, okay.
So total number of ways he can select a shirt and a pant is 150 ways, right?
Oh, yeah. Yes.
Right.
Understood.
Similarly, if you wanted to go shirt and kurta, so let's draw it here maybe. So how many ways are there? 10 ways to select a shirt and 20 ways to select a kurta. So total
Select
number of ways
kurta.
are
Yeah. 20,
200
200.
ways,
Yeah.
right? Similarly, uh, 15 ways to select a pant and
20
20
ways.
ways to select a kurta. So it is
Yeah.
around 300 ways,
300.
right?
300.
So total ways are 150 or 200 or 300. So it's like total 650 ways. Understand?
Understood. Understood. Yeah.
Okay.
My understanding was like, the shirts and
Yeah,
pants, they all
only
are.
shirt and pant. I
Yeah,
understand.
that's what. Yeah.
That's fine. It's okay. But
Excuse me,
it's clear, right? Yeah.
can I ask you a doubt from the
Yes.
tutorial?
So maybe we can at the end we can discuss it. That's fine.
All right, okay,
Okay.
all right.
So this is it, right? So this is 650 should be the answer. Okay. Now this is the question one. So there are 10 shirts, 15 pants, and 20 kurtas. Raj has a gift voucher with which he can buy item or two items. So you understand here he can buy either one item or he can buy either two items.
Yes. Yes.
So now you have to find a total number of ways. So now you have to be careful. So first question, what we did, we found out the number of ways he can buy one item, right?
Yes.
And the second question, what we did, the number of ways to buy two items. Now the question is, he can either buy one item or two items. So how many ways are there?
Oh, okay. Yeah.
Okay.
So
Done, sir.
Sir, your mic is mute, sir.
A small doubt in the question. Is that one item or two items? Is that right?
One item. First question.
Okay.
My understanding was like he can buy one item or two items.
Oh, this question. Yeah. Sir, your mic is mute, sir.
Okay, sorry. I'm just forgetting. Okay, so I think the 695 is the correct answer because this is the just addition of the first question and the second question, the number of ways which you have found out for one item. And because here you can see he can either buy one item or two items. So whenever you see or, it means it's addition, right?
Yes.
Okay, let's go to the question 2. There are 5 hats numbered 1 to 5. These 5 hats should be distributed to 6 people, with each person getting a maximum of 1 hat. Okay. What are the total number of ways in which the hats can be distributed to 6 persons? So there are 5 different hats. So when I'm saying what number from 1 to 5, that means these are the 5 distinct hats, and these hats has to be distributed to 6 people, and with each person getting a maximum of 1 hat. Okay, so one person cannot take 2 hats. So how many ways are there to these hats can be distributed to 6 persons? Okay, just do it carefully. Okay, while solving it, just think once and then solve this.
Sir. Hello, sir.
Yes.
Sir, for me, from this question, I'm not able to see answer the question, sir.
Answer the option tab is not there, sir, for this question.
Yes,
Okay.
sir. From
Okay.
this question, the answer tab is not there.
Okay. Okay. Just wait. Maybe this.
Hello.
Yes.
Sorry, sir. Sorry to interrupt. I just joined. I want to know what are we doing here?
See, we are doing this solve the session.
Okay.
Just a minute. There is a problem in the PPT. I guess I will just check once and I get back to
Okay.
you.
Okay.
Sir, in question maximum of 1 hat, so that means every person have a 1 hat, right?
Yeah, every person can have 1 hat.
Okay, the repetition of hats is allowable? The number?
No.
So then how it's possible to distribute the 5 hats into 6 people?
Right, no? That's why I asked you to think and try. I will tell you the answer anyway.
Okay. So the maximum is
Wait.
sir. So that is also unique number too.
Sorry?
That maximum the person have one hat and that number is unique for two. The hat number is unique.
Yes.
Okay, sir. Fine. Thank you, sir.
So where we are able to see the questions?
One minute. I just give me 2 minutes. I will just
Okay,
tell you.
okay.
Yes, sir, I can't see the box where to keep the answer.
Wait. Just wait for some time. I'm doing something here. So just wait. Okay, so yeah, now what I'm doing is I'm just using the another slide. You just use the other code. Okay, I'll just share my screen to you. My screen is not visible to you, right?
Yes, sir.
Is it
It's not visible. No, not visible. Not visible.
Okay,
It's not
okay,
visible, sir.
okay.
Not
Now
visible.
yeah, fine.
You can see.
Yeah.
Hmm.
So now use this code to enter. So go back again. Use this joinpd.com and we started from the new one.
Can you go to that slide? It shows the first slide.
Yeah, it's okay. I'll just change the slides. Okay. So I think we were in this question number 2. Right now you can write the answer.
5 टोपी हैं 6 लोगों में कैसे बांटूं मैं? कितने तरीके से बांट सकता हूँ ये नहीं पता मैं.
Done, sir.
Okay, fine. We'll wait for 1 or 2 minutes.
Sir, can I ask another question?
Okay, fine. Yeah, just go ahead. But
Yeah, sir. It's also just a concept, sir. We study stem leaf plot, right? So, but I can't find the where it is used in our practical life. That stem leaf plot.
okay, there are actually a lot of places we can use. But okay, maybe what we can do is maybe I'll just show you some things, or maybe I'll try to tell you some things which are. See that box plot. What it represents is quartiles, right? Like quartiles.
No, sir. No box plot. Box plot. We have a lot of applications. Stem leaf plot, sir.
Stem and leaf plot. Okay.
Yeah.
Stem and leaf plot. Okay. This practical applications, I won't say much are there, but see, this is
I
like
think it is a way to organize numbers.
You have to you can directly arrange these numbers, right? So you can see that they are already in the arranged order, right? So ascending order, if you wanted to arrange them, they are already in the order. So that is one thing, and maybe you can see the like if you have a large number of data, right? You can visualize that data like with the stem and leaf plot. If you, I think in one of the questions we need to find, right, 9 only stems should be there, right? So how you are like adding that all the data into one chart, that but okay, I won't say that much applications are there, but you can visualize it it's easier way to see the larger data in an order, so that I can say. So I won't say that where it can be applied precisely, I'm not sure about it. So it's kind of an visualization, I can say.
Yeah. So we are playing with integers in stem leaf plot. If it is a decimal, when what we do,
You
sir?
can use we can do, right? So I think we have one question there.
Question like that. So we just.
So the important thing to draw the stem and leaf plot is it is to create a key, right? So let's say you have 5.6, 5.7, 5.8. These are the numbers you are having. So you will say 5, that vertical line, and 6. It should be considered as 5.6, or it represents 5.6. So if you say that key, automatically the other person will understand. Okay, that 5.6 means 5.6, 5.7 means 5.7, 6.7 means 6.7, like that. So you have to mention it there in the key. Okay, I think so. Let's see first of all what are the answers. Okay, varied answers are there, but 120 is 120 and 720 are the common answers, I will say. Okay, let's find out which is the correct answer. Now there are 6 persons, right? So consider the 6 persons as P1, P2, P3, P4, P5, and P6. And there are a total of 5 hats, numbered from 1 to 5, and each person will get maximum of 1 hat. So firstly, these 5 persons are chosen from total of 6 persons in following ways. So why we are choosing 5 persons? Because we have only 5 hats. Right? So
Yes.
we have 5 hats.
So for
And they're mentioned also
what
maximum.
about last person, sixth person?
No, he won't get that, right? So only only if you have 5 hats and there are 6 people, so you can't give the 5 hats to all the 6 people, right?
Yes.
One person won't get the hat. That is the thing,
Yes.
right? So you have to choose 5 persons out of these 6, and then you will say that okay, these are the 5 hats, and you can take those hats. So how many ways are there to choose 5 persons? So you can see this P1, P2, P3, P4, P5. Then like this, if you arrange them, I think that are the 6 ways, right? If you know little bit of permutation combinations, you can definitely say 6P5, right? So not 6P5, it is 6C5. So selecting 5 persons out of the 6. So these are the ways, and in this number of ways, right? So you can see that these 5 hats are arranged now in 120 ways, right? Right?
Yes, sir.
Because first thing is you have to choose 5 people, right? And how many ways are there to choose 5 persons? These are the 6 ways, right? Correct?
Yes, sir.
and the next step is now you have 5 different hats. So what will you do? These 5 hats will go to this selected 5%. So how many ways are there? So first persons have 5 choices. He can have either hat 1, hat 2, hat 3, hat 4, or hat 5. Similarly, the second person, so once the first person gets first hat, one hat, then the second person will have 4 choices left, right? And the third person will have 3 choices left, and the second person will have, so fourth person will have 2 choices left, like that. So it will be 5 factorial ways. So the total number of ways the 5 hats can go to the 5 persons will be 120 ways, and the total number of ways the 5 persons are chosen for from the 6 people is 6. So 6 into 120 will be equal to 720. So the total number of ways will be 720. So the correct answer is 720, not 120. So 120 are the number of ways where you can arrange these 5 ads over the 5 people, right? Or 5 persons. But there are 6 ways in which you will choose those 5 persons. You understand?
Yes, sir, clear.
Okay. So the correct answer should be 720. Okay, so the third question is in a multiple select question, each question containing 5 options. So there is a multiple select question, and each question will have 5 options. And you know the multiple select questions in that more than one option can be correct. Okay, so the question is what are the total number of possible ways in which a student can select the answer to a multiple? So for one multiple select question, how many possible ways are there in which a student can select the answer? So you have to find.
Excuse me, sir.
Yes.
Sir, I still am not getting the answer to the question bar, sir. Can I solve in my paper and then check the answer, sir?
I don't understand. What are you trying to say?
No, sir. In the bar, we'll get answer the question to answer it, no, sir.
Uh,
I'm still not getting that bar, sir. Can I
okay. No, you can
solve and
use.
check
Okay.
that?
No, no, 1 minute, 1 minute. You
No,
can
sir.
actually.
I'm using the new code only, sir.
Okay, okay,
I'm
fine.
using this one only, but still I'm not getting that.
Okay, that's okay. That's okay.
So
You can solve and cross check with this. It's not a problem.
Okay, sir. Thank you, sir.
Okay. So think about this question carefully. Take 5 minutes and then try to give the answer.
Sir, a small doubt. Hello? Hello?
Okay, so there are 15, 15, 31, 325. Okay, I can see different answers. Let's check out the solution then. Okay, so you can see that there are 5 options to one multiple set question, right? And more than one option can be correct. So how many ways, what do you think, like a student can select one option out of the 5, right? That is one possibility, correct? Then
Yes.
student can select 2 options out of this 5, right?
Yes.
Or student can select 3 options out of this 5, or student can select 4 options out of the 5, or students can select 5 options out of the 5. This is okay, this clear, right?
Yes.
So maybe this is something, okay, somewhat O1 O2 something is there. Oh, let's try to find out in some simpler way maybe. So listen to this. So let's say this is 5 options are there, right? So student can select one option, right? Student can select 2 options, so, or students can select 3 options. This is all right, right? Or he can select 4 options, or he can select 5 options. Okay, so in how many ways a student can select one option out of this 5? There are 5 options, right? Or there are how many ways in which a student can select 2 options?
10.
20.
10 ways.
10.
How many are there?
20. 10.
20, 20.
Okay, 10 or 20?
10, sir.
20.
Ten,
Okay,
20,
sir.
sir.
so O1 O2, let's say, then O1 O3, O1 O4, O1 O5, right? Is okay?
Yeah.
O1
Yes.
is option 1, O2 is option 3, like that, right? These are how many ways? 5. Sorry, 4, right? Then O2, O3, because I cannot say O2 on, right? Because O2 on is also the same thing, right? So O2 O3, O2 O4, O2 O5, right? Then we have O3 O4, then we have O3 O5, right? That's correct. And then we can have O4 O5. So how many ways are there? These are 4,
10.
these are 3, these are 2, these are 1. So it is total of 10, not 20, because we are considering O1 O2 same as that of O2 and O1, right? Because if he selects O1 first and then O2, or if he selects O2 first and then O1, it doesn't matter, right? So that that order does not matter here, correct? Right? So hence the 10 options are there. If that order matters, then 20 will be the correct answer. But currently the order does not matter, and hence it is, so I cannot say that this only 10 options are there. So okay, in the same way, can you tell me in how many ways a student can select 3 options?
10.
15.
10.
10, right? Okay,
Yes.
again, to select 4 options, how many ways are there?
5.
5. How many ways he can select
1.
one option? 5 option is 1.
1.
So you can see 1 plus 5 is 6, 6 plus 10, 16, 16 plus 10, 26, and 26 plus 5 is
31.
31, right?
Yes, sir.
Sure.
So you can see the correct answer should be 31. Understand?
Yes.
No, sir, I don't understand. Can you please repeat this question?
Yes, sir.
Okay. So okay, you tell me the so let's say you have 5 options in one multiple selected question, right? So if you are going to select one option, in how many ways you can select one option?
5 ways?
How?
Option 1 or option 2 or option 3
Either you
or
can
option
select option 1, right? Or
Yes.
you can select option 2, or you can select option 3, or you can select option 4, or you can select option 5. So right, so either you can select one option, first option, or the second, or the third, or the fourth, or fifth. So all of these, how many are there?
5.
5 ways. Similarly, if I wanted you to choose 2 options out of the 5, so either you can select option 1 and 2. Okay, this is one way, right? This is one way. to select two options, right? Or you can select first option and the third option,
Yes.
right? Or you can select first option and fourth option, or you can select first option and fifth option, right? So how many these ways are there? Four. Similarly, you can select second and third option, second and fourth option, second and fifth option, like this. So if you uh, add all these options, it will become 10. Similarly, if I wanted to select, so if you wanted to select three options, how many ways you can select? Tell me the possible combinations. So it will be option 1, option 2, and option 3, right? This one way you can select three options, correct? Right, you will be selecting first option, second option, and three options when I asked you to select three options out of the five, right? Is correct?
Yes, sir.
The second way is option 1, option 3, option 4, or option 1, option 2, option 4, or option 1, option 3, option 5, or option 1, option 2, option 5, or option 1, option 4, option 5, right? These are the possible combination in which you can select three options out of the five, right? Right?
Yes, sir. Yes, sir.
Or what you can do, option 2, option 3, option 4, option 2, option 3, option 5, option 2, option 4, option 5, right? Or else option 3, option 4, option 5. So how many are there? 1, 2, 3, 4, 5, 6. 6 plus 1, 2, 3, 3 plus 1. So total of 10 ways in which you can select three options, right? So this I have added here. Similarly, you can check for option 4. So those will be what? Now you can tell me what are the possible ways in which I can select four options. O1, O2, O3, O4, or
O4, yeah.
O1, O2, O3, O5, or O1, O2, O4, O5, right? Or O1, okay, O1 is completed. I think that's then O2, O3, O4, and O5, and O2, O. Okay, this is also the last option. I think. Then what else you can?
I think, sir, it's easily calculated by NCR formula.
Yeah, but it is
So
not there in this week,
do we
right?
have to do this lengthy things every day?
No, not required. Not required. But I'm just showing you how that formula comes, right? So that anyway we'll be studying in week 6. So you can just find out that using the 5C4 or 5C5 like that. But currently those who are new to this, for them I'm just showing what are the possible things, right? Okay.
Okay, sir.
Okay. So 1, 2, 3, 4, 1, 2, 3, 5, maybe 1, 2, 4, 5. Okay. Then 2, 3, 4, 5. Oh, what else is there? Maybe one more option is there, but O1, O3, O4, O5. Yes. So these are the five ways. So I have written here those five ways, right? So 5 plus 10 plus 10 plus 5, and the remaining five options you can select in only one way: O1, O2, O3, O4, O5. This is one way. So total number of ways are 31. I hope it is clear to you. You just can solve it by yourself also. Okay. Okay, so this question number 4 is find the ratio of the number of three-digit numbers, all digits being even, okay, whose digits either increase or decrease from left to right to the number of three-digit numbers. I think we have discussed it in the grade assignment. Just try to solve this question. Just take few minutes, maybe 5 minutes, and solve it.
I did not understand the question.
Can we consider 0 as even number?
Can somebody explain what I have to do here? I did not understand the question.
You have to select either the even numbers 0, 2, 4, 6, 8 or odd numbers 1, 3, 5, 7, 5, 7, 9 and form 3-digit number. It should be an increasing order. It's like if you are selecting 2, then that another number should be 4, 6. Then if you are selecting 4, 4, 6, 8, then 2, 6, 8 is also possible. Like that, you have to select either increasing or decreasing, both ways, and total it. In that way, even numbers and increasing, odd numbers also increasing and decreasing way. Total number of possible ways. How many possible ways you can create? Yeah, like that.
Okay, got it. Thank you.
So do we have to consider 0 as even or not?
Yeah, 0 even.
Even, right?
Yes.
Can the numbers be repeated?
I don't think so.
Okay, so I don't think a lot of people are able to solve this question. Let's. I think I have already. I think in one of this last session, I think I have mentioned this how to solve this. But let's. Okay, I think we'll see the solution and the answers which I am seeing here. They are all different. So let's see which is the correct answer. I think there is only one common answer is 0.7. Apart from that, nothing is common. So let's see which is the correct solution. Okay. Okay. So okay, how many even digits are there?
5, sir.
0, 2, 4, 6, 8. These are the 5 digits. Even digits are there. And how many odd digits are there? 5. So
Yes.
these are 1, 3, 5, 7, 9. And question is, we have to find the number of 3-digit numbers and whose digits either increase or decrease from left to right. Okay. And to the number of 3-digit numbers which is being odd. So first of all, let's try to see which are the numbers, like which are possible. Like if you wanted to see the 3-digit number, right? That means, okay, let's okay. So which are the available digits we are having? Even digits. Let's talk about even digits first. So these are 0, 2, 4, 6, and 8. And you have to create or you have to find a 3-digit number, right?
Yes.
Right? Or you have to so by using all these 5 digits. So if I keep 0 here, what will happen?
It is become 2-digit.
Two-digit number, right? Because
Digit
0
number,
to
yes,
4,
sir.
0
Yeah.
to 4 is not a 3-digit number; it's a 3-digit number, right?
Yeah.
Correct? So we can't
Mm.
keep 0 at this place, right? Thousands place, right? Is 0, sorry, hundreds place, right? Place. Okay, I don't know what is the place. Okay, let's say. So, but we can't keep have 0 at this place, right? So, what are the possible ways I can have here? I
Four
can put
possible.
2
Two
or
ways.
4.
4.
Four.
Yeah,
2
that's
for
what.
6.
6 I can't put because
Yeah.
I need to prepare or I need to find
Increasing order.
Yeah.
I increasing, right? So if I have 2 here, then I can have 4 here, then 6
6,
here, right? Or I can have 2 here,
6, 8.
4 here, and 8 here, right?
Yes, sir.
It's fine. Okay.
Yes.
I cannot have 2, 0, and 6, right? Because after 2 it's decreasing and then it's increasing again. That should not be the criteria. The criteria is the digit should be either increasing from here to there or they will be increasing from here to there. So for example, 6, 4, and 2 is fine, right? Right? What is happening here? It's increasing from left to right, right? Right. And these numbers are decreasing from left to right. Is correct?
Yes, sir.
Right. So the choice of even digit numbers will be, so I cannot have 2, 0 here. I can have only 2 here at the start, right? So which are those numbers? 2, 4, 6, 2, 4, 8,
2, 6,
right?
8.
2, 6, 8.
4, 6,
These
8.
are the, so these are numbers I can find when I have 2 at this place, right? The first place. So
Yes.
again 4, 6, 8 I can have, no other possibilities there, right?
Yes.
After that, okay, these are all increasing from left to right. Okay, all decreasing from left to right. What are the possibilities?
8, 6.
6, 6, 4, 2, right? Or then 8, 6, 4, or 8, 6, 2. Any other number?
860.
Can we not take
Yeah.
860, 642,
Yeah, I can take
640?
860. Then I can
842.
have 840 also.
842.
842.
842. Okay, we didn't use a. Okay, fine. 842. Then
840, 820.
840.
820.
820.
820.
642, 640, 620, 420.
642 we have completed. So yeah, 640.
831.
Then
620.
how much? 620. Yeah.
831.
420.
420.
420. Yeah,
Yeah.
fine. So these are all these are all decreasing, right?
Yes.
And these are all
Increasing.
increasing. So
Total
how many are
14.
there? 1,
14.
2,
So why
3,
not
4, 5.
831?
We have to use only even digits, right? Not
Oh,
the
even
odd.
this.
So 831 will contain odd digit, right? So it is not
Oh,
possible, right? So we just have to use even digits. So total ways are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this
4.
4. 1, 2, 3, 4. So
Yeah.
total number of ways are 14.
14.
Similarly, if I want to use this odd digits, what will happen? 1, 3, 5,
So
7,
there will
9.
be
So you can actually find it out like 1, then 3, 5.
so there will be
That is,
20 ways.
yeah, I'll just, okay, maybe I'll just quickly I'll go through all the ways, okay? 1, 3, 7, then 1, 3, 9, right? Again, I can have maybe 3,
157.
3, 5, 7.
157.
Okay, okay, 1, 5. Okay, I'll put first of all. Okay,
We will finish the
1,
one
5,
first.
7. Yeah,
159.
159.
1, 9, right? Then
179.
179,
179.
right? And then I'll go with 3. So it will be 3, 5, 7, 3, 5,
359.
9,
359.
then
379.
3, 7, 9. Okay, then 5, 7, 9. These are all increasing from left to right. Okay, similarly, if I wanted to have the decreasing from left to right, I'll use 9 first, then 9, 7, 5, then 9, 7, 3, then 9,
953.
7, 1, right?
Yes.
Then I can have 9,
953.
9,
975.
5, 3, 9, 5.
975. 975.
Okay, okay.
That already
No,
wrote.
it's done, right?
Yes, yes, yes.
9,
Yeah.
It is there. First one. Yeah.
9, 5, 3, then 9, 5, 1. I think then 9, 3, 1. That's it, right? With 9. Then I'll
Yes.
start with 7, 7, 5, 3, 7,
751.
1. Then I can have 7, 3, 1.
3,
That's it.
1.
And then the last one is 5, 3, 1, right? I'm
Yes.
correct? These are decreasing from left to right. These are increasing from left to right. So how many ways are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total are 20 ways. So if I wanted to find the ratio, it will become 14, right? Because with even digits, there are total 14 ways, and divided by 20, which is equals to 7 by 10, right? Which is 0.7. 0.7 should be the correct answer. I
The
think
question was quite cryptic.
okay. So yeah, but I think that if you read it slowly, you will get to understand, I guess, right?
So somebody helped me to understand it. I could solve it, but then I did not realize you have to sum it for both the side and then find out the ratio.
Okay.
So
Okay.
I think more clarity is required in such questions.
More clarity. Okay. How do you want to have this clarity? I don't know. Okay. But okay, we will do.
Dividing ways in the question. Ratio of the number of ways all digits are even on the numerator side and all the digits are even, odd in the denominator side. You have to find the ratio
Okay. Okay.
of that ways.
But okay, that will become too simple. Okay, but still okay. Still you have to use the logic. Okay, we'll try to add that kind of thing, right? Okay. But this logic is clear to you, right? How to solve that question?
Yes, yes, yes.
Yes.
Yes, sir.
Okay, fine. So shall we move to the next question then?
Yes.
We have
Yes, please.
like okay, we have some more questions left. So how many numbers between 0 to 1 billion can be formed using only these three digits, 0, 1, 2? So how many digits are required to have 1 billion number? Like how many places should be there in 1 billion? Okay, 1 million, how many should be there? 1 million is 10 lakhs, right?
10 lakhs.
6.
10 lakhs.
Yeah. 6 digits.
How many? 6 places, right? Or 6
7.
digits?
6 zeros
10 lakhs,
and
7
7.
digits.
2.
So
Okay.
in 1 million,
7 digits per million. Billion.
1 million, 7 digits, 6 zeros.
Yeah,
okay.
100 crore.
Yeah, just find it out. If you don't understand, just Google it. how many digits are required. All these digits you have to fill with only 0, 1 and 2. So okay, again, while solving this question, remember that if you put 0 at the first place, that number will not become 1 billion, right? So you can't have that 0 at the first. You have only two choices, 1 and 2 there, and after that you can use any other digits. So you can use 0, 1 or 2. And one more thing, if you can see is, let's say you have maybe 9 places. So what will happen in the 9 places? You have to use only 3 digits. So with the question itself, it is clear that the repetition of the digits are allowed. Okay, so no need to mention the separate thing that repetition is allowed. You can just think of and you can understand that the repetition is allowed there. Okay. Okay, I think enough time is given, so let's see the solution. Okay. Okay, so okay, you can see how many digits are required. If you see the 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 digits should be there, right? Right?
Yes, sir.
Right. So we have to fill this with uh, 0, 1, and 2. So how many ways you can do that? So 0 cannot be here, right, at the first place. So here you can have only 1 and 2, right? And you have to use the same numbers at other places. So you can see, suppose.
Sir, I have one doubt. So why the 0 is not in the first place? Because if it is in the first place, then that is also possible. Because
No, that is possible, but it won't become 1 billion, right? More than 1 billion, right?
But the question is, what are the possible numbers lies between 0 to 1 million, 1 billion, right?
Okay, is it your question?
So 1, 2, 3, that is also possible, sir.
Oh, okay, fine. Okay, in that case, you can fill there. Yeah, okay, that's fine. So how many ways should be there? What do you think?
I think 3 to the power 10, sir.
No, I think you are right, sir. We cannot keep on the first digit. We cannot keep anything other than 0, because we need number from 0 to 1 billion.
I think we can keep, because
no,
see,
because 1 billion is 1 followed by 9 zeros, right? If we keep 1 there, it becomes 1.
No, we have to find all the numbers between 0 to 1 billion. So okay, okay, leave about
we can
0
keep
to 1 billion
only
thing.
0 or 1. We can keep there, not
Okay,
all.
okay, 1 minute. I'll just.
In fact, 1 also we cannot keep. Only once 1 we can keep, right? When all are zeros.
Wait, if you take the first 9 digits is 0, then last digit is 1. So that is also lies between 0 to 1 billion, right?
Yeah, but once we take 1 there, everything else has to be 0. We cannot
Okay,
take anything else beyond that.
Maybe don't go about that million thing. Just will think about how many numbers are there between 0 to, let's say, 100. Only I can use these digits. Okay. So which are the numbers you will fill?
99 numbers total, right?
No. With only these 3 digits.
Okay. So 1.
First will be
1.
1.
2. 10. 11. 12. 20. 21. 22. Then that's all, is it?
That's it, right?
Yeah.
So this one is
100.
what? No, 100 you can. So 0, 1 and 0, 2, right?
Yes, sir.
Right. So you see, you have only 2 places to fill, right here. When even though, because it is, when I said it is between 0 to 100, then that means it will exclude this 0 and exclude this, right? When I say between 0 to 100, that means we have to exclude these 2 numbers. So I will have only 2 places to fill, correct? Right?
Yes.
Okay. How many possible ways are there? I'll put it here. I can have 0 also here, right? Because you can see it's 0 when is a valid number to be in between 0 to 100, correct?
Yes.
So I can have 0 here, or I can have 1 here. You can see.
So 3 possible.
I can have 0 here. I can have 1 here. I can have 2 here.
Yeah.
Right? So I can have how many? I can have 3 ways, right?
Yes, 3 and 3.
And 3 here, 0 or 1 or 2. So 3. So total number of ways are
9.
This okay?
Yeah, fine.
Okay. Similar concept if I wanted to use between 0 to 1000, right? So how many places we should fill? What do you think? Because this is excluded, right? 1000.
Yes.
So we have 3 places.
So we have 9
so
ways, or we have 8 ways?
9 ways, right? Here.
But it is 8, right? On the left side, what number we counted?
Okay, so I think it's okay, 3 to the power 3. Okay, which case we should exclude is
0, 0 is also possible.
0, 0.
Okay.
0, 0 cannot be possible, so I have to subtract it from here. So total 8 ways.
Okay,
right?
sir, I have a
Because
doubt.
0, 0 becomes this 0, right?
Yeah,
That
so
means we have to exclude
between
this.
0 and 100 is included or excluded, sir?
Excluded. Excluded both the numbers, right?
Okay, sir.
Okay, so that means 8 ways are there. Okay, similarly, if I wanted to use for 0 to 1000, so I need to because the maximum number I can reach is 999, right? And the minimum number should be 001, correct?
Yes.
In between, right? So that means I have to fill these 3 places. So, and by using, let's say 0, 1, 2. So how many ways are there to fill this place? 3.
3.
Again 3 into 3.
7
So it will be
minus
27 and minus 1. Minus 1 for what? This case 0, 0,
Yes.
0. So we have total of 26 ways, right?
Yes, sir.
Okay, now come to 1 billion. 1 billion means 10 digits, right? But
Yeah,
we
10.
should exclude this one, that this number, right? When I will say 0 to 1 billion, between 0 to 1 billion, then I'll have to exclude that number. So how many places should be there? I have to fill 9. 1, 2,
9.
3, 4, 5, 6, 7, 8, 9. This is okay.
Yes,
And
sir.
if I wanted to use only 0, 1, 2, then I'll have 3 ways here. 3, 3, 3, 3, 3, 3, 3, 3. So it will be 3 to the power
9
9
minus 1.
minus 1. Minus 1 for which case? This case 0, 0, 0, 0, 0, 0, 0, 0, right? So the correct answer should be 3 to the power 9 minus 1. So okay, fine.
Yes, sir.
Sir, there is 10 places, but why we are taking 9
Okay,
spaces?
okay. Similar to this, how many places are here in 1000?
4 places.
And how many places we have taken here?
3 places.
Why?
Okay,
Because this 1000 is
because we
excluded.
are not, yeah.
Right. So
Okay.
similar logic we are applying here for 1 billion. In 1 billion, we have 10 places. But since we cannot include this 1 billion, we have to select one place less. So it should be 9 places, right?
Okay.
Okay. So whenever you find such kind of big numbers, you can think the logic with the smaller numbers and you can translate that into the bigger number. Okay.
Excuse me, sir.
Yes.
Could you please repeat it once again? For the we are subtracting -1.
Okay. So
this
so
is if number is between 0 and that given number.
Okay. বাথরুমও
I
পেয়েছি
think
যে বাথরুমটা করেছি
okay, somebody speaking. Can you just
sir, should I go ahead?
muting myself? Yes, please. I think somebody was Kajri.
Yes,
okay, you just mute when you are speaking. Okay, okay. So I'll just maybe I'll just one more time I'll just ask you. So what is your name? Sorry.
I am
don't
Sudhir
know.
speaking.
Okay, Sudhir. Okay. So if I wanted to find the numbers between 0 to 100, okay.
Yes.
So when I say between 0 to 100, that means I will count only which numbers from 1 to 99, right?
Right.
I will not include 0 and I will not include 100, right?
Okay. Okay.
And if I wanted to use, let's say, only 3 digits, this 0, 1, 2, right? I'm not using all the 9 digits or 10 digits. I will just use only 3 digits. So which are the possible numbers you will feel between 0 to 100? So that is 0, 1, right? Then 0, 2,
0, 2,
then
1, 0,
1, 0,
1, 2,
1, 1, 1 also be 1, 1
1,
is
2.
fine, right? 1, 2, okay, let's say 1, 2,
2, 0,
2, 0 and
2, 2, 1.
2, 1. So how many ways are there? 1, 2, 3, 4, 5, 6. I think we have missed something, right?
1, 1, 2,
1,
2.
1 also. Yeah, 1, 1 also we can do, right?
22 and 11.
Yeah. 1, 1 and 2, 2 is fine, is also there, right?
Okay.
So total of 8 ways are there, right? How many ways are there? 8 ways. Okay. So when I wanted to find between 0 to 100, so how many digits are, or how many places we need to fill these digits? 2 places, right?
Okay, sir.
So first place, how many choices I'll have? I can have 0 at the first place, 1 or 2. So how many ways are there? Three choices are there, right? At the first place, I can fill between 0 or 1 or 2. Similarly, on the second place or units place, how many choices I'll have?
Again 3.
1, I can put 0, I can put 2, right? So again 3. So total number of ways are
9.
9 ways. But this will include which of the possibility? I can have 0 at this place and I can have 0 at this place, right? But that 0 0 means 0, right?
Okay.
Here. But this I don't want, because I don't want to consider 0, right? Because I'm finding the numbers between 0 to 100. So I can't include this 0 in our
Right.
list, right?
Okay.
So that's why I need to subtract this 1 from the 9 ways. So it will become 8 ways, and you can cross check these 8 ways and these 8 ways are the same, right? So similarly, if I wanted to find between 0 to 1000, so I need to check how many places, or I need to fill how many places? 3 places, right?
Okay, sir.
Then I have 3 ways here, 3 ways here, 3 ways here. So total of 3 to the power 3 ways, right? But this will include this thing also, right? 0 0 0.
Okay, all zeros.
So I need to subtract it. So similar logic I have applied for that 0 to 1 million. So I have to fill that 9 places with 3 to the power 9, and I'll subtract one way which will include all zeros at 9 places. Right?
Okay, sir. Thank you, sir.
Okay.
Single, not wait mingle. Single and happy. We are already mingled, na? So what can you do being single?
Okay. So yeah, let's go to the question number 6. How many? Okay, I think this. Okay, this is the same question. The only difference is we have to use the digits 1, 2, 3. Previously, which digits we have used? 0, 1, 2, right?
1, 2.
Now, okay. Now you just find it out. Take like maybe 4 minutes. 4
I
to
think it
5
will be
minutes.
same answer, right?
No, just check. It should not be same. Just check.
Just that -1 doesn't apply.
Yes, correct. So yeah, just take 2 or 3 minutes maybe. Now you have already disclosed that. So let's see. Let's see.
Yeah, you're right. -1 won't be applied because 0 0 0 was never part of that. These are like some number
Correct.
system, right, sir?
So
Like
correct answer should be 3 to the power
3 to power x.
Yeah.
10.
So it should be 3 to
9,
the power
sorry.
9.
Yeah.
9 here. Okay.
So
Fine.
it's like that number system, right? Like binary, you have 2 to power. Then for ternary, you may have 3 to power. For
okay. Yeah, you can
yeah.
think of like that only. Yeah. Fine.
Yeah.
So okay, this is the wrong solution. It should be 3 to the power 9. Okay. Let's skip that question anyway. That is not the difficult one. Let's try to solve this one. Suppose that number of runs scored of a delivery. What does that mean? In one delivery or one ball, if a bowler throws one ball to a batsman, how many runs a batsman can score is in between uniform in 1, 2, 3, 4, 5, 6. So he can either score 1 run or 2 runs or 3 runs or 4 runs or 5 runs or 6 runs, independent of what happens in the other deliveries. Okay. A batsman played 3 deliveries and find a number of possible outcomes such that he hit 3 runs of at least one delivery. So you just understand this. So anyone don't understand that question, just let me know. So batsman has played 3 deliveries, right? That means 3 balls. He has played 3 balls. Okay. And we need to find the number of ways in which he will hit 3 runs at least of one delivery. Or that means let's say in the first ball he scored 1 run. Second ball he scored 4 runs, and third ball he scored 3 runs, right? Or in the first ball he scored 3 runs. In the second ball he scored 2 runs, and the third ball he scored 4 runs. Or it may be he has scored 3 runs in the first ball, 3 runs in the second ball, 3 runs in the third ball. So you have to find a number of possible ways in which he can at least score 3 runs in at least one of the deliveries. Okay, just try it. Take some time, try it, and then we'll see.
It's the question is still not clear to me. I'm trying to understand, but I'm a bit confused about the question.
Yeah, even I did not understand. I thought I'll read it 2-3 times and understand, but I'm not able to.
Yeah,
My understanding is that a batsman has played 3 deliveries, okay, and he has scored 3 runs. What are the possible ways that he can score those 3 runs?
No. So what does this 6 deliveries uniform, the inside the bracket, what it shows, what it tells?
Those are the possible runs that he can score.
Okay, so out of those 3 deliveries, one of these 3 he has already taken, is it?
No. See, out of the 3 deliveries, he has scored 3 runs.
Okay.
Yeah.
Okay.
Oh, 3 runs of at least one delivery. Okay.
And that means 300 is possible?
Yes. It is possible.
Yeah, thank you.
And this is my understanding. I don't know.
Okay.
Yeah, then your understanding somehow contradicts with what it tells, right? Delivery is uniform in 1, 2, 3, 4, 5, 6, independent of what happens in other deliveries.
Yeah, even I think he explained it that way only.
मैं क्यों नहीं
Maybe when I read further, it looks like my understanding is wrong.
Yeah, I think it tells the batsman can either score 1, 2, 3, 4, 5, or 6.
Exactly. It looks like when I read it further, it looks like he played 3 deliveries and he has scored 1 ball 3 runs, and the other 2 balls he can score any other like 1, 2, 3, 4, 5, 6 runs. I think.
I think he's saying uniform, so the every scores will be have equal possibility.
I think minimum is 3 runs at least. So next one will be 3, 4, 5, or 3, 4, 4, or 3, 3, 3 like that. He can't take 1, 2 runs. Is this correct?
Neither I played cricket nor I understood the question.
Not so. Let him come. We'll ask.
Yeah, question is not clear.
Yeah, I think.
Or I mean, I'm not able to understand.
For one delivery, he is getting at least 3 runs. So for next delivery, he should get more than 3 or equal to 3.
Idea. Not sure. Just wait.
3 deliveries, then find.
Okay, what's the problem?
Sir, we could not understand the question.
Okay, so there are 3 balls, right? Okay, so for example, let's say let's take the example that let's say Virat Kohli is playing, okay, and maybe you can take one of the bowlers. Let's say Ashwin. Ashwin is bowling balls to the Virat Kohli. Okay, so Ashwin has bowled 3 balls to the Virat Kohli, right? So in the first ball, he can score any one of the runs, right? Either he can score 1 or 2 or 3 or 4 or 5 or 6, right? Okay, that is okay. In the second ball also, he can score any one of these runs, 1, 2, 3, 4, 5, 6. In the third ball also, he can. So how many choices each ball will have? 6 choices, right?
I think the 6 into 6 into 1.
1 minute, 1 minute, 1 minute.
Okay.
But we have to find the possible outcome such that he hit 3 runs of at least 1 delivery. So in these 3, right, we are constraining that he has to score 3 runs in one of the delivery. Either he can hit 1 3 run in the first ball, or he can hit 1 3 run in the second ball. So you have to fix that position. So for example, first ball he scored 3 runs. Then in the second ball he can score any one of the run, maybe 1 2 3 4 5 6 or 1 2 3 4 5 6. So how many ways are there? 6 into 6, right? And this can happen in one of the 3 deliveries, right? Okay, maybe I'll discuss the solution itself. Anyway, I'm trying to give the hint, but I'm discussing the solution itself, right? Okay. So is it okay, right? I'll show the solution. It's fine, right?
Yeah. Yes.
Sir, is the answer is 127?
I'm not sure. I'll check. Okay, we'll solve and then I'll tell you. Okay. 3 balls are there, right? So let's say first ball. So I'll represent first ball by this place. Okay. Then I'll represent this by second, and this is third. Okay. So he can score 1 2 3 4 5 6 in one of the balls independent of the. So if he scores let's say 5 runs here, that does not dependent on the second ball, right? Or if he scored 3 runs here, this 3 runs does not depend on the 5 runs he scored in the first ball. That is what we wanted to say. So and he has to score at least 1 3 run, right, in one of the balls, right? That means he can.
It means that repetitions are allowed.
Yes, repetitions are allowed. And one more thing is, maybe he can score 3 runs in the first ball, or maybe he can score 3 runs in the second ball, or he can score 3 runs in the third ball. So first case is, let's say case 1. Case 1 is at least 3 runs in one ball means, sorry, at least one ball he will score 3 runs, right? So that means he can score 3 runs in one of the ball out of 3, right? Case 2 will be he will score 3 runs in 2 balls out of 3, right? And third case will be he will score 3 runs in 3 balls. Okay. So in the first case, what will happen? He can score 3 runs here or here or here, right? This is okay?
But he can score 4 or 5 also, right?
Yes. Just think of whatever I'm trying to say, just follow that first. Okay. So case 1 is what? 3 runs in one of the balls, right? So let's say take one case as, let's say he has scored 3 runs here, then he has scored 4 runs here and 6 runs here, right? Or so I'm fixing this place that in the first ball he has scored 3 runs, then he can score 1 here and then 5 here, right? Like that. So okay, so if I say he has scored 3 runs in the first ball itself. First ball. How many choices I have? I can he can score in the second and third ball, but he should not use 3 runs here, right? Because he has already scored 3 runs in the first ball.
So 5 choices.
Here 5 choices. Here.
Yeah. Another 5 choice. Yeah.
So total base.
120.
No,
75.
25.
25.
Okay.
This three is not a way, right? 3 is the one way only, right? In one way only
he
he can
can't
score.
run 3 and 3 and 3.
He can, but we are considering only the first case. First case means 3 runs in one of the balls, right? So I have considered that in this case he has scored 3 runs in the first ball itself. So total number of ways 25, right? Or else I'm going to fix 3 runs here. In the second ball he has scored 3 runs. So how many ways are there? He will score 5 other runs in the first ball, 5 ways, right? And one more 5 ways here. So total of 25 ways, right? So this combination will look like how it will look like. It will be like 1 3 6 1 3 5 1 3 4 1 3 2 1 3 maybe 1 maybe 1 3 or maybe any other possibility, right? 6 3 1 6 3
Excuse me, sir.
6, but 3 is fixed here in the middle position.
Excuse
Right?
me, sir.
Yeah.
I have a doubt. What I understood is he said at least 3 runs. So other 2 deliveries should be more than 3, right? Not
Is
that.
is it not the at least 3 runs? It is he has to score 3 runs of at least one delivery.
Oh. Only in one delivery 3 should be there. Other deliveries it can be
Can have any numbers. So that possibility we are checking, right? So suppose he has scored.
Can he not score 3 again? Repeatedly, like first.
He can do, right? Okay. So okay. First of all, let's segregate this. Okay.
No,
at
because
least
distribution is uniform, so he cannot.
No, he can. So let's say okay, at least one
No, but
delivery means what?
It says a uniform distribution, right? Not
uniform doesn't matter here actually. It will matter when you have the probability. Okay. Uniform. Okay, keep it aside for now. Just see the simple thing first.
Okay.
What does that mean at the end? That end sentence is very important. What is the end sentence? He has to hit 3 runs, right? Hit 3 runs in at least one delivery, right? At least one means what?
Any of 3 deliveries he has to hit once 3.
Once, right? So he has to hit 3 once. At least once. At least means he can have 3 once. He can hit 3 twice also, or he can hit 3 thrice also, right? At least one means at least once, twice, and thrice, right? So I'm checking this possibility that he will hit 3 once. This is my case 1. Okay. So hit 3 once means he can hit 3 in the first delivery, right?
Sorry to interrupt. So in that case, then it should be 1 times 6 times 6, isn't it? Because 3 can be repeated.
So 3, okay.
The first case that you discussed earlier, we made as 1 multiplied by 5 multiplied by 5. So it should be 1 multiplied by 6 multiplied by 6 because 3 can be repeated.
Okay, 3 can be repeated. It's okay, but okay. Let's tell me if you are saying 1 multiplied by 6 multiplied 6. What does that mean? In the first position, what?
He hit 3 runs first delivery, and the second and third.
He can score
any score, yeah.
But this 6 contains what? 1, 2, 3, 4, 5, 6, right?
6, yeah, 6.
So that means he can score 3 here. He can score 3 here also, right?
Correct.
But both possibilities are covered here, na? That's why.
When I wanted to say once, that means that 3 comes only once. Either it can have 3 here, I can have 3 here, right? You're
All
understanding
right.
my point?
Yeah, I understood. But why
So
do
then,
we impose the condition?
because
Once, three once.
Because it is written that at least once, right?
Yeah.
At least of one delivery. At least one delivery means, okay.
At least for one ball, you would have hit 3 runs. You scored 3 runs.
Huh. So at least
Okay.
one means what? In the at least out of the 3, he'll score once 3, right?
Correct. So that doesn't stop him from scoring 3 runs for the next 2 balls too, right?
Correct. Oh, okay.
So we don't have to restrict there. Yeah, that we don't have to impose that condition. I mean, that's what I feel.
If we say 6 into 6 into 1, then all the conditions are covered here, because it can be first can be 3, second can be 3, or first cannot be 3, second can be 3, and all.
Okay. Maybe
we'll see the solution. Okay. Oh, but it's
so 25. Case 1 will be what? Okay, maybe you can read it once. Maybe if you understand it like this.
I think the problem is I haven't understood the question properly still. So
okay, I'll try to give you some different problem maybe, because that 3 is getting confused to you maybe. So let's think of
Can
it
we
in
take
another
the
way.
case one like the first ball is 3 and the second ball has 6 options and third one has 6 possibilities, and the second case would be like first ball can have 6 possibilities, second ball can have 1 possibility, and third one has 6 possibilities. And
6 is
similar the
not
third
possible, right?
condition.
No. I think you are getting missed there. Okay, maybe we'll try to do it for 2 balls. Okay. Maybe maybe I'll say the 2 things. Okay, just let me think some other problem. Okay, so let's take this example. Let's say you have 2 deliveries. Okay, 2 balls, fine. 2 balls, and you can score uniformly between on each of the ball, independent of each other. You can score 1, 2, and 3. Okay, and I will say you have to score at least you have to score 1 run at least of 1 delivery. Okay, this condition is fine, right?
Yes.
Okay, so that means you have to score at least you have to score 1 run at least of 1 delivery. So you have 2 balls here. What are the possible ways I can have? We have 2 balls. So how can I score 1 and
3?
Any 1, 2, or 3.
Okay, maybe we'll start, or we'll write down all the possible cases. 1 is okay, right? At least 1 means what? I can have 2
Correct.
also, 2 times 1 also,
Correct.
right?
Yes,
Okay,
sir.
then I have 1,
1,
2,
2.
right?
Yes.
I
1,
can
3.
have 1, 3. Okay.
Yes.
I can have okay, that's it with 1, right? I'll start with 2. I can have 2, 1.
2, 2, 2, 3.
Right? 2, 2 I cannot use because I need to score 1 run, right?
Oh, yes.
So I cannot use 2, 2.
Yeah.
I will use only 2, 1, right? Fine.
Then 3, 1.
I can have 3, 1. All these are the possibilities, right? That's it, right?
Yeah.
That's it, right?
3.
How many ways
Yep.
are there?
5 ways.
5.
5. So with what your logic you are saying, so previously what you said, I can have 1 here, right? in the first position, then how many ways should be there to fill the second place? 3.
3.
So it will be 3.
Yeah.
Okay. In the second case, you wanted to say I will have one run in this place,
and
I
there 3.
can have 3. So total of 3.
6, 3, 6.
So okay, 3, right? And total ways 6. But this is contradicting this statement, right?
Yeah. Why is that?
Why? Okay, I'll tell you now. So in at least of one delivery, that means I can have one here, right? I can have, when I say 1 and 1 here, that means I can have 1 in 2 deliveries also, right? So let's say I have fixed my first position with 1. That means my batsman has scored 1 run in the first place, in the first ball. Okay. But my case 1 is, I'm saying that the batsman will score 1 run of exactly 1 delivery. Okay. Exactly 1. In that case, I can have 1. So my batsman will hit 1 run in the first ball. And how many options I will be remaining with in the second ball? Only 2, right?
Yeah.
No,
I can,
can you repeat this again? I mean,
so okay, I
one
need to one run of exactly 1 delivery. Exactly.
Okay.
Right?
Is that the meaning of the question?
I will
Should I
tell
understand
you.
it that way?
Yes. So I'm just trying to get into that question's language. Okay.
Okay.
So let's say my batsman has scored 1 run in the first ball. Okay.
Okay.
So how many ways are there he can score in the 2 balls, the second ball? Either he can score 2 or
3.
3. He cannot score 1 because I said this case is 1 run of exactly 1 delivery, right? So if he has scored 1 run in the first ball, I will be remaining with the 2 cases, right?
Yeah.
So 2. So total number of ways 2.
2.
Which are these 2? You see, I will highlight these 2 ways.
1, 2, and 1, 3.
1, 2, and 1, 3,
1, 3.
right? Okay.
Yeah.
The next possibility is my batsman has scored 1 run in the second place.
Okay.
Second ball. So how many ways he can score in the first delivery? Only 2 or 3.
2 or 3.
Yeah.
So
right?
2 possibilities.
2 or 3. So 2 possibilities. So 2 ways. Which are these 2? These 2.
Yeah. So 2 plus 2, 4 then.
Right? Now, this is my case 1. The case 2 will be, because when I say at least, that means I can go for more than 1, right? He can score 1 run in more than 1 delivery. Right? That means of 2 deliveries. Correct?
Okay. Yeah.
So he can score 1 in the first delivery and 1 in the second delivery.
Second delivery.
This is the only one way, right? So this is that. So total number of ways are 5. So what we have considered case 1 as 1 run of exactly 1 delivery, right? Case 2 is 1 run for more than 2 deliveries. That will include in at least, right? What does that mean, at least? At least means it can happen once, or it can happen twice, or it can happen thrice, or whatever number of how many we wanted to go, right? So same logic if I wanted to apply for
Just a second. No, please show me that screen. Yeah. Now, what is the difference between the one which we defined earlier here, like 1 times 3 and 3 times 1, which came to 6, and the one I still don't understand.
Okay. In this way, in this case, right? Okay, I'll write down all these numbers. 1 times 3 means what? We have considered 1.
1.
3 ways means what? 1, 1.
Yeah, 1, 1, 1, 2, 1, 3.
And the
1,
second
3.
is 2, 1.
2, 1.
Then
2, 3. Sorry.
2, 3,
yeah,
and
2, 3. We left 2, 3.
And 1, 1.
Okay. Oh,
3,
so
right? So we are doing it again. So I need not to take it this, right? So it
no.
will be 6
I think 2, 3 cannot happen.
Okay,
that
sorry.
might be the reason.
Okay.
That might be the reason.
Yeah, sorry. 2, 3 cannot happen, and okay, we can have 3, 1, right? We can have 3, 1.
You can have 3, 1. So 2, 1.
No, sorry. No. 1, 1 is coming. So okay. Let's go with this. Okay, how did you find out the 6 ways? I have fixed 1 here,
1,
right?
yeah.
And I am saying that 3 ways. What are the 3 ways? I can have
1,
1, 2,
1,
and
2,
3.
1, 3. Yeah.
So this is 1, 1, 1, 2, 1,
1, 2,
3.
1, 3. Okay.
The second thing is 3 ways here into 1. So it means
correct. So it becomes
so this 3 means 1, 2, 3. So it will be 1, 1.
Okay.
Right? 2, 1, 3, 1. But this
1, 1 is
1, 1
repeating.
I'm 1, 1 I'm calculating once again, right? I need not to calculate that. So this is the mistake I'm
So it's a
doing.
combination
Right?
display. Okay.
Right. So okay. So this logic, if I wanted to apply for 3 balls, right? And at least of 1 delivery. So I have 3 balls here. Okay. So first case, what I'll define is 3 runs of exactly 1 delivery. Okay. So I'll fix my first position where I'll score 3 runs. So I'll remain with how many ways? 5 here.
Yeah.
5 here. Right.
5 there.
Because I cannot use 3 again.
No. As per this, as per what we have done just now, it should be 6.
Okay.
Isn't it?
Are you not considering this 1, 2, 3, right? I'm talking about the our problem.
The real problem, the real question. Yeah, no, if we are going to go about with the method that we just discussed here a moment ago, then it should be 6 times 6, isn't it? 3, 6, 6.
Why 6?
That is what and then we are cancelling out the common 1, 1.
Okay. Why? No. Don't go with the common cancelling out, because if you do that, it's not simple for your mind to calculate, because here we had just considered 2 balls. There is a possibility how you can you won't understand in that number of ways, like 100 ways. How many ways you wanted to cancel out, you won't understand. It won't be one way. Okay. So the way to think is you have to create the cases, which we just exactly did here, right? So I said 1 run of exactly 1 delivery. That means in the first place, he has scored 1 run. Now he can score 2 or 3, right? He cannot score 1 again, right? In another case, I'll say he's going to score 1 run in the second ball. So he's not going to score 1 run again in the first delivery, right? And in the second case, what we'll do? One run more than 1 delivery. So he can score 1 run in the first delivery. He can score 1 run in the second delivery. So that's how we are going to.
That is how you're calculating. Okay.
Right. So now just come to the question. So we have 3 balls here, right? So the first case I'm considering is case 1. I'll say the batsman will score 3 runs in exactly
1 delivery.
one delivery, right? So that delivery might be the first one, right?
Okay.
So in that also 3 cases will be, right? So let's say in the first delivery he has scored 3 runs. This is not number of ways; these are the runs he scored. So how many ways he can do that? 1 way.
1 way.
Okay. So I said 3 runs. I said 3 runs in exactly 1 delivery.
Exactly.
So in the second ball, how many runs he can?
It should be 5 and 5.
5 and 5. So total number of ways are 25 ways. Right? Similarly, I have. So he can score 3 in the second position.
Okay.
Right? So how many ways are there? Only
again
1
the
way.
same thing. Yeah.
Right. So total of
again it repeats.
25 ways. Similarly, 5
and 1.
25 ways.
25.
Okay. Now I'll consider the case where I'll say 3 runs.
All
no, in 2 deliveries.
Oh,
this will
okay.
also come, right? This will also
yeah,
come,
that's right. Right.
So he can score 3 here.
Yeah.
3 in the first 2 deliveries. So how many ways are there? 1 only, right?
1,
out
1
of the 6.
and 5. Yeah.
And
5.
Similarly, he can do 1 here, 5
and 5.
And one more thing is 1 here and 5.
Right? 5. Okay. So we get
total of
15 ways there.
5 and
5 and 5.
Okay. Now then we go for case number 3, where he can score 3 runs in all deliveries, right? So all are 1 into
that is one possibility.
1 way. So total ways are 25 into 3, 75, plus 5 into 3, which is 15,
90,
plus 1,
91.
total of 91 ways.
So, but the question is quite complicated. It really confused.
So this kind of questions you can think of that you have to think of these questions. So if you solve more and more questions, you won't feel this complexity there. Okay. Because maybe you are seeing it for the first time.
First time, yeah, that's true.
Yeah, that's why it is like you are feeling that constraint. Once you solve this kind of questions, I think you will be able to solve. So you can just practice it more and more. Okay. But you'll understand the logic right now.
Yeah, understood. Yeah.
Okay. So all of you guys, you understand this?
Yes, sir.
Okay. Okay. So let's. Yeah, I know this is like it's kind of difficult question to. If you are seeing for the first time, it will be difficult. But if you see such kind of problems again and again, you won't feel that, because these problems will translate into probability in the week 7. Okay.
Sir, my question, these in Q2, which weeks questions will be there? All 8 weeks or from 5 to 8?
So 5 to 8 more weightage will be there, but some questions will be coming from week 1 to 4 also. So maybe 1 or 2 questions from week 1 to 4, and the remaining will be from week 5 to 8. So you can just focus more on week 5 to 8, and then if you get time, you can just brush up week 1 to 4. Okay. So question 8 is Rohit wants to set a 4-digit password for his phone. Okay. Out of those 4 digits, the first 2 digits are alphabetical and the remaining 2 are numeric. Both uppercase and lowercase alphabets can be used in the password, and repetition of alphabets allowed, while repetition of numbers is not allowed. So think about this: repetition of alphabets allowed and repetition of numbers is not allowed. What are the total number of ways? So I think we have discussed in the previous session also, but yeah, just try it once, then we'll discuss.
I think done, sir.
Sir, I joined late, so should I put the answer in the chat box?
Hello. Okay. So shall we discuss the solution then?
Yes, sir.
Okay. So let's discuss it. So first of all, tell me how many digits or how many places we need to fill. Am I audible?
Yeah. 4 digits.
Okay. So we have 4 places or 4
places.
digits.
4 places.
Okay. Right. Okay. And the first 2 places will be filled with alphabets. Right. Alphabets. Maybe lower
Caps and lower. Yeah.
upper. Right.
Upper and lower. Okay.
And the second 2 digits should be filled with the numbers.
Numeric.
Right. Okay. And for first 2 digits, it is repetition is allowed.
Yeah.
Right. And the last 2 digits or places, the repetition is not allowed. Okay. So tell me how many lowercase letters are there? 26. And how many uppercase are there? 26. Right. So total 52. Right. A, B, C, D up to Z is 26. Right. So both lower and upper will include 26 and 26. It's 52. Right. So first place can be filled with how many ways?
52.
52. And second place,
Again,
since the repetition is allowed, I have all the 52 choices to fill this place, right?
Yeah.
So I can use again 52. Okay. What about third place? We can use numbers. So numbers will be from 0 to 9. So how many digits are there? 10.
10.
Right? Or 10 numbers. So first place can be filled with
10.
10. That means first means in the sense third place, right? Okay.
Yeah.
And the repetition is not allowed. Then I can fill this place, last place, with 9. Right? So the total will be 52 into 52 into 10 into 9. So these are the total number of ways. Right? It was easier question, right? So we'll see calculations. Yeah. So 52 into 10 into 9. So that should be the correct answer. Okay. So this is the last question we are going to have. So total number of ways in which 4 boys and 4 girls can be seated around a round table, so that no 2 girls sit together is equal to. Okay, you have to find. Okay, maybe. Okay, so what you can do is you can solve this question, or you can think of about this question, and maybe we can solve this question in the next week. Because with permutation and combination principles, right, this will be somewhat easier. So note down this question. I will share the slides with all of you with the solution also, but note down this question. We'll discuss the solution in the next week. Okay. Okay. So any other doubts apart from this? Somebody has asked me about week 3. I'll take that one, and then I'll close the session.
I had a doubt on tutorial 1, but I don't know if you have the time now.
No, you can ask. Tutorial 1. What is
tutorial 1 is that 6 men and 4 women couple. I mean, they form a couple. In a building, there are 6 men and.
Yeah, I think we have discussed in the last. Maybe you haven't joined. Okay, so there are 6 men, right? So let's say M1, M2, M3, M4, M5, and M6. And we have let's say 4 women. W1, W2, W3, and
W4. Okay.
These are the 4 women. Okay, and I think they are saying that there should be 3 couples, right?
3 couples.
3 couples. Okay. So how many ways you can choose 3 women out of this 4?
3 women.
Yeah. So let's say, yeah. So W1, W2, W3.
Okay.
W1, W3, W4. Right. W1, W2, and W4. Right.
Okay.
Then W2, W3, W4. Right. Then,
okay. 4.
So I think these are the 4 ways, right? 4 ways in which you can choose 3 women out of this 4. Right. Now,
sorry to interrupt. This particular definition I too heard in the video there. But my question is, generally what we do is we try to form the couple. So it could be M1 W1, M1 W2, M1 W3,
Right,
M1
but
W4.
it will become complicated, right? So how can
No,
you
I just got
write down all those
24.
number of waves? You can find it out. It's fine. M1 W1, then you can have
M1 W2.
so once it's M1 is went with W1, then I cannot use M1, right? So it will be M2 W2, and then M3 W3, right? Or
Okay.
M1 W1, M2 W2, and M3 will go with W4, right? Again M1 W1, M2 maybe W.
No, isn't there an easier way? Like, shouldn't we multiply 6 times 4? Simple.
6 times 4, I don't think that will be the correct answer. But so that's what, okay. In the next week, when you see the permutation combination, right, it will be very easy. So in that case, so it will be, let's say 4C3. It will be 4 factorial upon 3 factorial into 1 factorial. That these are the number of ways you can choose. So it will be 4. Right?
Yeah.
And how many ways you can select 3 men out of this 6? It should be 63, right? It will be 6 factorial into 3 factorial into 3 factorial. So if you do this calculation, so it will become so 6 into 5 into 4 into 3 will go, say 6 and 6. So it will be 20 ways.
20.
And if you multiply these ways, I think it will be 80 ways, right?
80. Is that it?
Yeah. So if you understand this permutation combination concept, it will be easier. But with the so since this week 5, we have only 2 videos, right?
Yeah.
So I'm not going to that definition currently.
All right. Okay, then I'll wait. Okay, we'll go through this.
That's why I'm not doing that 9th question also. Because I think once you are done with the permutation combination, it will be easier for me also to explain. Because writing down all these ways, it will be like
yeah, that's very.
It will take a lot of time, right?
Right. Yeah.
Just to give the hint of like how this combination will work, I'm just writing down today. But maybe we are not going to do it in the next sessions. Once you study
All
that,
right. All right.
There will be some people who will be seeing all these things for the first time.
Okay. Thank you.
Okay, guys. I think that
so what to do with this graded assignment EMCs? Well,
EMQ, right? If you are able to, because I think I got some requests that we haven't studied about repetitions and or maybe replacement and non-replacement this week. So what I'll do is I will just increase the deadline of submission to maybe along with the deadline of week 6. Okay, only to this which one? This EMQ thing, right? I'll do that thing for the this EMQ. The grade assignment week 5, you have to submit it by maybe tomorrow. But EMQ you can submit it along with week 6. So once you study week 6, maybe you will be well versed with the repetition allowed or replacement without replacement, all those concepts, and you might be able to be in the better position to submit that assignment. Okay.
Okay.
Fine. Anyway, that assignment is not graded, but I'll increase the deadline for it also, right?
Oh, it says graded.
No, we won't calculate. So anyway, don't worry about it. We'll say we'll make it as non-graded. Okay.
Okay. Thank you.
Okay, guys.
Thank you, sir.
Yeah. So I think we'll stop. Whatever doubts, anything will be there. We'll do it in the next sessions. Fine.
Thank you.
Okay, guys. Thank you. Good
do we
night.
have open sessions next week?
Yes. We have. Those will continue until week 12.
We never had this week, right? Was there any open session this week? No,
There,
right?
it was there.
Okay. Yeah.
Okay.
I will see. I will look into the YouTube video. Thank you.
Fine. Okay, guys. Okay, bye.